Okay, today we're going to be looking at volume of prisms and cylinders. Okay, you'll find that majority of the volume problems that we'll be dealing with in this unit is going to be based on the formula that the volume is equal to the area of the base times the height. So the capital B means the area of the base, and the height is usually the vertical height of a figure, but sometimes the figures are laid on their sides, so it's the segment that connects the two bases. And you'll see what I mean when we get to those figures. Okay, so here in number 1, when we're dealing with prisms, the way that we name a prism is by the shape of the base. And the definition of the base or basis, if it has two bases, is the set of sides that are parallel. Now, if it's a rectangular prism, it really doesn't matter which side or set of sides are going to be your base. So here, we'll come right here, we're going to say the volume is equal to the area of the base times the height. Well, the shape of our base is a rectangle, and we know that to find the area of the rectangle, it's simply length times width. So right here, we're going to say 3 times 4, which gives us 12. So the area of the base is 12, and the height of our figure is also 12. So we get 12 times 12, which is 144. Since it's centimeters, it's going to be centimeters cubed. Now, in middle school, you probably learned that to find the volume of a rectangular prism is length times width times height, and that's perfectly fine to do. Okay, for number 2, we have what's called a square prism, or sometimes we call it a cube. But it's still a rectangular prism because a square is a type of rectangle. So again, we're going to simply come right here and say the volume is equal to the area of the base times the height. Our base is a square, so the area is equal to the side squared. And I don't expect you to do it like this every time. Usually I'll put it right here, but just as a refresher, I am writing the formulas for the area of the bases. So here we would have 5 squared, which is 25. So the area of our base here is 25. The height of our figure is 5. And 25 times 5 is 125, and that would be centimeters cubed. Volume is always in cubic units. All right, for number 3, we can see here that our base is a triangle because those are the two sides that are parallel. So this is called a triangular prism. All right, so again, to find the volume, we're going to say the area of the base times the height. Okay, well, to find the area of the base, that's a triangle, so we know that it's 1/2 base times height. So we're going to come right here, we're going to say 1/2. All right, the base of our triangle is 8. The height of our triangle is 5. Half of 8 is 4. 4 times 5 is 20. So the area of the base is 20. Now the height. The height is this segment right here because it connects the front base to the back base. So the height of this figure is 10, and 20 times 10 is 200. So that gives us 200 centimeters cubed. All right, for number 4, we've got a trapezoidal prism, okay, because the shape of the base is a trapezoid. So once again, the volume is going to be the area of the base times the height. But let's find the area of the base. So to find the area of a trapezoid, it's equal to 1/2 the sum of the bases times the height of the trapezoid. Okay, so right here we're going to say 1/2. All right, this front base of the trapezoid is 6. The back base of the trapezoid is 12. So 6 plus 12 is 18. And the height of the trapezoid, not the prism, but the trapezoid. All right, we can see right here, they're giving that to us as an 8. Okay. All right, half of 18 is 9. 9 times 8 is 72. So right here in place of the area of the base, we're going to put a 72. The height of the prism. All right, this 10 is the height of the prism because we can see that's the segment that connects the bottom base to the top base. So 72 times 10 is going to give us 720, and that's going to be meters cubed. Now, if you did not print the notes and you need to draw these, you can always pause the video at any time to draw these and then watch the video to get the notes. All right, now here once again we have a trapezoidal prism. So if you will pause the video, I do want this to be a U-try. Okay, so hopefully you've paused the video, and I'm going to come right here and find the volume. So we know the volume is equal to the area of the base times the height. So the area of a trapezoid is going to be 1/2 the base plus the base. All right, so here's the bottom base of 14. My top base is 6. So 6 plus 14 is 20. And then the height of the trapezoid, not the height of the prism, but the height of the trapezoid right here is 4. Half of 20 is 10. 10 times 4 is 40. So the area of my base is 40 times the height of the prism, where the height of the prism is going to be 25. Okay, and let's see, 40, well, that's 25. 4 times 25 would be, what, 100? Add a 0, so it's going to be 1,000 centimeters cubed. Hopefully you got that one right. All right, number 6 is a triangular prism, but it's more specifically a specific type of triangle. It is an equilateral triangle, and we can tell that by these little tick marks. They mean that all 3 sides are congruent. We're still going to do the volume is equal to the area of the base times the height. To find the area of an equilateral triangle, the formula is the side squared onto the square root of 3 over 2. I'll give you a second to copy that down. All right, so here we're going to come right here. Our side is 8, so we got 8 squared on square root of 3 over 4. Oh, I put it to that. It's supposed to be over 4. My bad. Let me take that out right there. That's supposed to be over 4. All right, over 4. All right, so here 8 squared is 64. We're going to get 64 onto the square root of 3 over 4. 64 divided by 4 is going to give us 4 goes into 6 one time, leaves a 24. 424 is 6. So we get 16 onto the square root of 3. So we get 16 onto the square root of 3. All right, the height of our prism is 12. And 16 times 12 is going to give us 192 onto the square root of 3 meters cubed. All right, so far we've looked at a triangular prism, a trapezoidal prism, a rectangular prism, all right, and a cube. Well, before we can look at our next 2 types of prisms, we need to do a little bit of review about regular polygons. Okay, and there are going to be 2 main regular polygons that we work with, and that's a hexagon and a pentagon. All right, what makes a polygon a regular polygon? Well, they have to be both equilateral, which means all the sides are the same, and they also have to be equiangular. Oops, I can't spell it or anything, can I? Equiangular, which means all the angles are equal. Okay. All right, so that's the definition of a regular polygon, equilateral and equiangular. The area formula for a regular polygon is area is equal to 1/2 the apothem times the perimeter. All right, the apothem. All right, what is an apothem? An apothem is simply the segment from the center of the figure to the side. Okay, so right here, this is an apothem. Okay, so now, like I said, we're going to be working with two regular polygons that are the most popular, and that's the hexagon and pentagon. And we need to be able to come in here and figure out what is the angle of these. Well, when we used to have the geometry course, we used to find all this lovely information about all kinds of shapes. And one of those pieces of information was how to find each angle of a regular polygon. And this is the formula. N minus 2 times 180 divided by n gives you each angle's measurement, where n is the number of sides. So like here, for a hexagon, the hexagon window has 6 sides, obviously 1, 2, 3, 4, 5, 6. All right, so to find what each angle here would be, we would say 6 minus 2 times 180 divided by 6. So let's see, basically 6 minus 2 is 4 times 180, and then we're going to divide it by 6, and we get 120. So each angle in here is 120. Now, when you're working with an apothem, usually you have to work with a radius. And the radius of a polygon goes from the center to a vertex. Since this is a regular polygon, what's going to happen here, if this whole side is 10, this side right here is going to be 5, this little piece, because the apothem goes to the midpoint of the opposite side. Okay. Now, also, since it's a regular polygon, that radius is going to split that angle. It's going to become 60. So we need that length right there. Okay. All right. So I'm going to come in here and use an old set of rules. You can use trig, but I'm going to use a set of rules that we used to teach on a regular basis, but due to the pandemic, we haven't taught in the last year and a half due to constraints and all. But when you have a special right triangle that is a 30, 60, 90 triangle, these have a set of formulas. Opposite of 30 has a formula of x. The hypotenuse is 2x, and opposite of 60 is x onto the square root of 3. So that means whatever this side is, like if this was 4, this side would be 8, and this would be 4 onto the square root of 3. So right here, we've got x is 5, so the apothem, which is opposite of 60, is going to be 5 onto the square root of 3. So now let's find the volume. It's equal to the area of the base times the height. Okay, so we have to come in here and find the area of the base. Okay, so the area of the base is going to be 1/2 the apothem, which we found to be 5 onto the square root of 3, times the perimeter. There are 6 sides, and each side is 10, so 6 times 10 is 60. Half of 60 is 30. 30 times 5 would be 150. So for the area of the base, we get 150 onto the square root of 3. Oh, Lord have mercy. It's a long day, y'all. All I had to do was find the area right here. I'm thinking of the area of a prism. That's coming up next. So let me go through that again. All right, all we have to do, again, is say 1/2 the apothem, which is 5 onto the square root of 3, times the perimeter. 6 sides, each side is 10, so that's 60. Half of 60 is 30. And 30 times 5 is 150, so here we get 150 onto the square root of 3. That is the area. All right, for a pentagon. Okay, so again, we've got to come in here and we're going to find out what each angle measures. So we're going to say 5, pentagon has 5 sides. 5 minus 2 times 180 over 5. So we'll say 3 times 180 divide that by 5, and we get each angle is 108. So when I draw my apothem, this piece right here is going to be 3 because the whole side is 6. Each angle is 108, so that means when I split it, it's going to become 54. Well, 54 is not a special right triangle. The special right triangles are your 30, 60, 90s and your 45, 45, 90s. Okay. With this one, we're going to have to come in here and use trig. So I need that apothem. So let's look at what this is going to look like. I know this is 54, this is x, and this is 3. So I have opposite and adjacent, which I know is tangent. So I'm going to say the tangent of 54 equals x over 3. Now, let's make sure that our calculator is in the correct mode. It's got to be in degree mode. Since I'm looking for the numerator, I'm going to multiply. So I'm going to say 3 times the tangent of 54, and that's 4.1. All right, so the area is going to be equal to 1/2 the apothem, which is 4.1, times the perimeter. All right, there are 5 sides, and each side is 6, and 5 times 6 is 30. All right, so since this was a decimal, I know I can end up with a decimal answer. So I'm just going to come right here and say 0.5 times 4.1 times 30, and that gives me 61.5 for the area of this regular pentagon. All right, so let's see how this is going to apply when we are working with a regular prism. All right, here we got a hexagonal prism, and I know this is a regular prism because they only give me one value here, so that's going to be the value for all the sides. The volume is equal to the area of the base times the height. Well, the height is easy. The height is just 9. But we need to figure out what the area of this base is. So we're going to say 1/2 the apothem times the perimeter. We just learned that when you have a hexagon, that little angle right there is going to be 60 when you draw in your radius. Okay. This is going to be 6. All right, so let's see, let's come right here. What we've got, I'm going to draw the triangle a little bit bigger so we can see it. All right, so this is 60, this is 6, and I need this length right here, so that's 30. Opposite of 30 is x, opposite of 60 is x onto the square root of 3. So if x is 6, that means this side is going to be 6 onto the square root of 3. So I'm going to have 1/2 6 onto the square root of 3 times the perimeter. All right, each side is 12. We got 6 sides, so 6 times 12, that's what, 72? Yep. All right, 1/2 of 6 is 3 times 72 gives us 216. So the area of our base is 216 onto the square root of 3 times the height of 9. All right, so 216 times 9, that's going to give me 1944 onto the square root of 3. Now, sometimes they might ask you to round this to a decimal, so just do that. So each time for a prism, what you've noticed I've done is found the area of the base times the height. Now, the base formula is going to change each time depending on the shape of the base. Okay, so keep that in mind. Each time that B is going to represent something different because the bases change for the prisms. They're not always going to have the same shape for the base. However, when we are dealing with cylinders, all of them have the same base for their shape. Let me rephrase that. They have the same shape for their bases. They're all circles. Since they are all circles, we know the area of a circle is pi r squared. So we can replace that B with pi r squared. Finding the volume of cylinders are extremely easy. So let's come in here and find this one. All right, so we've got the volume is equal to pi r squared times h. Because again, this is a circle. And they're all circles. So we're going to say 4 squared, which is 16 pi times our height of 5. 16 times 5 gives us 80, so we get 80 pi. Now, this, remember, is called the exact answer because you leave it in terms of pi. Sometimes they might ask you to round it. So let's say that we had to round it as 2 decimals. And we would come in here and multiply it by pi, and we would get 251.33. And of course, this would be centimeters cubed. And this up here would also have been kilometers cubed. For number 9, they're giving us the diameter instead of the radius. So if all the way across is 6, then half of that would be 3. So to find the volume, we're going to come right here, and we're going to say pi r squared times the height. So our radius is 3, so we've got 3 squared pi times the height of 4. 3 squared is 9. 9 times 4 is 36. And that would be centimeters cubed. All right, for number 10. Okay, all right, notice that here that our cylinder is laid on its side. So this is still the base. The circles are still the base. So this is our height right here. Okay, so I'm going to come right here and we'll say pi r squared times the height. My radius is 3. And my height is 8. So 9 times 8 is 72. So we get 72 pi. And this had no given unit, so we're just going to leave it like that. All right. Can't accuse me today of not giving enough examples, huh? All right, so here we got some what I call the odds and ends problems. Okay, so let's look at how these odds and end problems are going to work for us. Okay. All right, so in number 11, basically they're going to ask us to work backwards. They're giving us that the height of a cylinder has a volume of 30 and a radius of 1. If you want to, you can draw the cylinder. All right, we've got a radius of 1, and the volume is equal to 30. How do they get that 30? First thing I notice is that there's no pi with it, so they've converted pi to 3.14 and multiplied. But let's just work backwards. Okay, so we got volume is equal to pi r squared times h. In place of volume, I'm going to put 30. I've got my pi, I've got my radius, and I'm trying to find my h. All right, well, 1 squared is still 1, and so we end up with just 1 pi, and the opposite of multiplying by pi is dividing. And so here we're going to get our height is equal to, all right, I'm going to do 30 divided by pi. Rounding to 1 decimal, we get 9.5. So your height here is approximately 9.5. For number 12, this is what we call a composite figure because it's several shapes that have been kind of pushed together. All right, so what this consists of basically is 2 shapes. I see 2 rectangles. And you can draw it 2 different ways, well, several different ways. I see this rectangle right here, and then I see this rectangular prism right here. So I'm going to find the volume of each one of those rectangular prisms, and then I'm going to add them together. All right, so let's do the little one first. All right, this is 2, and I can see the little tick mark there, so that means that is 2. All right, so we've got, this is 4, and I'm assuming this is 2 as well, and then this right here is 10. So I'm going to kind of go old school and do length times width times height for this one. So I've got a length of 2, a width of 2, and then a height of 10. 2 times 2 is 4. 4 times 10 is 40. So my little one is 40. All right, now let's do the larger one. Okay, so here I've got 10, I've got 6, and I've got 4. Six times 4 is 24, times 10 is 240. 40 plus 240 is going to give us 280. Now, You may have done it this way right here. You may have said, well, here I'm going to use this rectangular prism and shaded it this way, and then this rectangular prism. You can look at it different ways. All right, for number 13, we've got two prisms here. We've got a rectangular prism, and then we've got a triangular prism. So for this one right here, I am going to go old school again. I'm going to do length times width times height. Okay, so I've got 14 times 9 times 8 plus, all right, now here for my triangular prism, I'm going to do the area of the base. So here I've got 14, so 1/2 times 14 times the height of the base, 5, times the height of the prism. So the prism, triangular prism would be 9 for the height. Okay, so let's see what all we got going on right here. All right, 14 times 9 times 8 plus 1/2 times 14 times 5 times 9. And we get 1323. So here our total volume is 1,323 inches cubed. All right, 14, the toilet paper problem. It does look like a roll of toilet paper, but it's actually called a cylindrical shell. Okay. Here, what we're going to do is we're going to find the volume of each individual cylinder, and then we're going to subtract them. With a composite figure, you add them. You find the individual volumes and add them. With figures that are usually like shaded region, where it says find the area of the shaded region or something, what they want you to do is find the volume of each piece and then subtract them. So I'm just going to do the volume of the big one minus the volume of the little one. Okay. So, all right, the volume of the cylinder, the larger cylinder. Okay, that's going to be, my radius is 50, so 50 squared pi times the height. Oops, I think I left off the height. Let's make the height, let's say 12. Okay, so times the height of 12 minus, the radius of the little figure, the smaller cylinder is 20, so 20 squared pi times the height of 12. Now, I'm going to leave it in terms of pi. So let's see, we got 50 squared times 12 minus 20 squared times 12. Okay, so we're going to get 25,200 pi for our volume. And again, I didn't give any units, so we're just going to leave it like that. All right, for number 15, all right, if you notice, we've got half a cylinder here. So we're going to find the volume of the cylinder, and then we're going to take half of it. So if the if the diameter is 14, the radius is 7. So we're going to come right here, we're going to say 7 squared pi times the height of 20. And then we're going to divide it by 2, or take a half. Okay, so 7 squared is 49. Half of 20 is 10, and 10 times 49 would be 490. So we're going to get 490 pi. And finally, for number 16, notice I gave you a little hint. We've got to use the Pythagorean theorem. We've got the diameter is 11. So half of that would be 5.5. Okay, so coming right here, let's see what we got to do here. We've got, this is 14. This is 5. Oops, actually this would be what, 11. My bad on that one. I'm jumping ahead of myself. That's 5.5. All right, so Pythagorean theorem, we're going to say 14 squared is equal to 11 squared plus a squared. So we end up subtracting 11 squared from 14 squared. So 14 squared minus 11 squared, and that's going to give us a squared equals 75. Okay, so taking the square root, we get 25 times 3, which is 5 onto the square root of 3. So here the height is 5 onto the square root of 3. Now, since I'm only working with a decimal, I'm just going to change the final answer into a decimal. So I'm going to come right here, and I'm going to do the volume is equal to the area of the base times the height. So it's a circle, so pi r squared, so 5.5 squared times pi times the height of 5 onto the square root of 3. All right, so you can see how I put it in the calculator. And when we round this to the nearest 1 decimal, to the nearest tenth, we see it's going to end up just being 823. Whew. All right, let's see. We got a 30-minute video, so I'm going to call it time here. I will make a second video for the word problems part, but for right now, I think this is good enough because I am out of steam. It has been a long day. I hope everyone has a wonderful afternoon, morning, whatever time of day it is for you.